and Energy, Part 2. We are on physical and chemical changes. Physical changes. A physical change is when the matter has been changed or altered. However, the molecules have not changed. They have not been altered. No new substance is formed. For example, if I have a piece of paper, I rip it, I tear it, I crumple it up. The chemical makeup of this paper has not changed. The molecules in this paper are still paper. This is a physical change. Also, a change in state, meaning from a gas to a liquid, or a liquid to a solid, or a solid to a liquid, or a liquid to a gas. It does not matter. If I have an ice cube, and that ice cube melts, and then that melted ice cube, water, evaporates into water vapor, and then the water vapor cools and condenses, and then it rains, and then the temperature drops and it freezes again back into ice. All of that is still a physical change. The chemical makeup of that water is still H2O. It is still water. It doesn't matter if it's a solid ice cube, liquid water, or water vapor, it is still an ice cube. All of those are physical changes. Any change of state, liquid, gas, solid, is a physical change. Breaking something, I break a pencil. The chemical makeup of that pencil has not changed. It is still a pencil. Any type of mixture. You put M&Ms and your Chex cereal and pretzels and you mix it all together. It's a physical change. Each of those items keep their own chemical qualities, and the makeup of that substance is still the same. It's a physical change. Same thing with dissolving. Okay, you put your Kool-Aid mix in your water and you stir it all up. The water keeps its chemical properties and the Kool-Aid mix keeps its chemical properties. It may be fully dissolved throughout, but a chemical change has not happened. It is a physical change. Making your Kool-Aid is a physical change. Most physical changes are reversible, okay? Meaning that if you put the mixture together, you can take it back apart. Now, a chemical change, on the other hand, is irreversible, meaning you cannot change it back. When you have a chemical change, a new substance is formed, or the molecules of a substance have been altered, changed, or separated. For example, rust. If you have a nail that has been left outside, rained on, and exposed to the oxygen, it's going to rust. That rust is a new substance. It is a chemical change. Burning. If I have my crumpled up piece of paper and now I light that piece of paper on fire, it's going to become a new substance. It's going to become ash. That burning creates a chemical change. You cannot take that ash and tape it all back together and make it paper again. It is a new substance. It has been chemically altered. Oxidation. This is one that we did in class where we took the pennies and we put them in a vinegar and salt solution, and they started to turn green and brown from the oxidation. That is a chemical change. What happened to the Statue of Liberty is a chemical change. Mold on your food and mold on your bread is a chemical change. That mold is a new substance. You don't want to go back and make that bread again. It has been chemically altered. Now, there are some signs of a chemical change. Things that let you know, hey, a chemical change just happened. Signs of a chemical change are if it gives off a smell, it creates light, or it becomes a new color. If I mix a clear liquid with a red liquid and it turns blue, that's probably a chemical change. If I mix a clear liquid with a red liquid and it becomes red, it's probably not a chemical change. So if it becomes a new, unexpected color, that would probably be a signal of a chemical change. Also, another example of a chemical change is anytime something is baked. You make cookie dough with your mom and you put it in the oven and it comes out as yummy, warm, delicious cookies. Those yummy, warm, delicious cookies can never go back to being that cookie dough or that batter ever again. It is a permanent change. So cooking, rust, burning, oxidation, mold, those are all examples of chemical changes. Finally, mixtures and solutions. Mixtures can be separated, and the separated parts can be seen. This is things like your Chex Mix, your cereals, your Lucky Charms. Solutions are completely mixed evenly throughout. Solutions would be things like lemonade, Kool-Aid. When they're completely mixed and completely dissolved throughout, those are solutions. Now, both solutions and mixtures equal the sum of all of its parts. If I put 2 grams of sugar and 5 grams of lemonade mix in with 10 grams of water, okay, it's going to be 2 plus 5 plus 10, 17 grams of lemonade. The mixtures and the solutions are always going to equal the sum of all of its parts. If I add up all the parts, that's going to be the total weight of the final product. Matter cannot be created or destroyed. So if I'm going to put things together, the final weight of that matter is going to be when I add the mass of all of those parts. It's not going to be more, it's not going to be less. It's going to be the exact amount of adding all of those things together. And that concludes our video for matter and energy. Don't forget to do your activities, your flashcards, and your practice test on Quizlet, and take your final test in Google Classroom. Bye.